Do you remember what the world's first air-to-air nuclear missile was? It was a missile developed by the United States at the beginning of the Cold War, a weapon that could wipe out an enemy bomber fleet. It was the AIR-2 Genie missile. The Genie's creation stemmed from Washington's concern for its security when the Soviet Union successfully tested its first nuclear bomb in 1949. A bomb that was more powerful than the bombs the United States dropped on two Japanese cities at the end of World War II. Do you remember which American fighter jet was the first to be equipped with this type of missile? Yes, it was the Northrop F-89 Scorpion, the plane in the video's title. The F-89 Scorpion made aviation history as the first jet-powered aircraft designed specifically for interception, and the first combat aircraft equipped with nuclear weapons. The Scorpion's story began with its first flight on August 16, 1948. The United States Air Force welcomed it into service in September 1950. Manufacturers produced 1,050 aircraft in all variants, making the F-89 a reliable Cold War guardian. The aircraft's greatest achievement came on July 19, 1957. It became the only aircraft to successfully fire a live Genie nuclear missile during Operation Plumbbob, showcasing its exceptional defensive capabilities. Operation Plumbbob, the only live nuclear test. The MB-1 Genie stands out as America's ultimate symbol of Cold War nuclear anxiety. This unguided nuclear rocket showcased both technological breakthroughs and the frightening strategic mindset of the atomic age. The F-89J Scorpion made history on July 19, 1957. The Cold War produced many bold moves, but this one stands out. 5 Air Force officers and a photographer stood right under the nuclear blast. They wanted to show that the weapon was safe to use in overpopulated areas. The Air Force later claimed these volunteers received minimal gamma and neutron radiation. The test proved the MB-1 air-to-air rocket can be successfully launched by the F-89 aircraft at 19,000 feet MSL, with a radiation dose to the delivery crew within acceptable limits. This remarkable demonstration remains the only time anyone detonated a nuclear-tipped air-to-air rocket. The F-89 Scorpion never fired a shot at enemy aircraft, but one strange event stands as the most notorious chapter in its operational history. On August 16, 1956, 2 Northrop F-89D Scorpions took part in what became known as the Battle of Palmdale, an embarrassing episode where America's advanced interceptors tried to take down an unlikely opponent, a runaway drone. The Battle of Palmdale, when F-89s fought a drone. A bright red Grumman F-6F-5K Hellcat drone lifted off from Point Mugu Naval Air Station in California at 11:34 a.m. that Thursday. The Navy had planned a routine missile test where the unmanned, radio-controlled World War II-era fighter would fly over the Pacific Ocean as a target for new Sparrow and Eagle air-to-air missiles. The Navy handlers quickly realized something had gone wrong. The drone ignored radio commands and started a continuous left turn not toward the safe Pacific waters, but straight toward Los Angeles's dense population. A standard weapons test had suddenly turned into a potential catastrophe. The Navy called the Air Force for help when faced with an unmanned aircraft potentially crashing into Los Angeles. 2 F-89D Scorpions rushed from nearby Oxnard Air Force Base to stop the rogue drone. These Scorpions packed serious firepower 104 unguided 2.75-inch Mighty Mouse, folding fin rockets in each aircraft's wing-mounted pods. Taking down a slow propeller aircraft with supersonic jets seemed easy. The reality turned out quite different. The F-89 pilots caught up with the Hellcat at 30,000 feet, but their automatic firing control system failed. These interceptors lacked gun sights because they relied on automated targeting. The pilots had no choice but to aim their unguided rockets manually without any reference points. The next moments became legendary. The Scorpion crews launched all 208 rockets in multiple passes without hitting the drone once. A newspaper later described it as an unintentional bombing attack on Southern California. The Air Force faced major embarrassment afterward. Their rockets started several big fires: 150 acres near Bouquet Canyon, 350 acres in Soledad Canyon, and 100 acres around Placerita Canyon. Rockets rained down like hail on Palmdale. By sheer luck, nobody died despite rockets blasting through homes, shattering windows, and destroying property. The drone's adventure ended when it ran out of fuel and crashed in an empty area near Palmdale, finishing its 2-hour unplanned flight by taking down some power lines. This event exposed serious flaws in America's air defense capabilities. The Air Force's latest interceptors and rocket technology couldn't stop a simple propeller-driven drone. The Battle of Palmdale showed how removing traditional guns and relying too much on automated systems created unexpected problems. A military observer summed it up perfectly. Firing a salvo of rockets into an enemy bomber formation was one thing, but trying to hit a small single target was quite another. This lesson shaped the development of future weapons. Now we will talk about the technicalities of the F-89 Scorpion. Technical innovations of the F-89 Scorpion. The F-89 stood out from its peers with its distinctive scorpion-like silhouette and state-of-the-art technical features. These advancements helped the aircraft complete its vital mission to intercept enemy bombers under any conditions, day or night. The Scorpion's greatest engineering achievement was its unique control surface setup. Engineers equipped the aircraft with decelerants after the original flight tests. This Northrop-developed technology first appeared in their unsuccessful XB-79 prototype. Traditional aircraft used separate control surfaces for different functions. The decelerants, however, were clamshell-style split ailerons that served multiple purposes. These clever surfaces worked as standard ailerons for roll control and could split open above and below the wing to act as dive brakes. They also doubled as flaps when needed, giving pilots unprecedented control over their flight path. This versatile control surface became invaluable for an interceptor that needed both high-speed pursuit capabilities and controlled approaches in poor visibility. The decelerant concept became such a soaring win that other aircraft adopted it, including the Fairchild Republic A-10 Thunderbolt II and elements of the Northrop Grumman B-2 Spirit. Twin Allison J-35 turbojet engines powered the F-89 in an unusual configuration. The engines sat directly under the wings with intakes flush to the fuselage, creating a straight-through arrangement. This unique positioning gave the Scorpion its distinctive look, earning it the nickname, the world's largest vacuum cleaner, from pilots due to its low-slung intakes collecting runway debris. The aircraft's wing design favored stability over pure speed. In stark comparison to this swept-wing trend in fighter design at that time, Northrop chose an unswept, laminar flow wing. This unconventional choice guaranteed maximum stability at low speeds essential for an aircraft that often landed in poor visibility or relied completely on instruments. The Scorpion's engines evolved with time. Early production models received more powerful afterburner-equipped Allison J-33A21 engines, later upgraded to the J-35A33. These improvements helped the F-89D reach a maximum speed of 636 miles per hour, with a service ceiling of 49,200 feet and an impressive range of 1,367 miles. The most important advances in the F-89 program came from its electronic systems. America's first all-weather interceptor pioneered integrated radar and fire control technology that would shape interceptor aircraft design for decades. Early F-89 models combined the APG-33 radar with the Hughes E-1 fire control system. This setup guided 6 20mm cannons in the nose, giving the Scorpion formidable firepower. The F-89D variant marked a turning point when it arrived in January 1953. It featured the state-of-the-art Hughes E-6 fire control system with an APG-40 radar and an APA-84 computer. This advanced electronics package automatically guided the aircraft toward predicted target positions, enabling successful interception in darkness or bad weather. The weapons system changed from guns to rockets specifically. 104 Mighty Mouse, 2.75-inch, folding fin aerial rockets stored in wingtip pods. The F-89 became the first aircraft designed to carry all rocket armament, which transformed interceptor doctrine completely. The F-89H variant brought more electronic improvements with the newer Hughes E-9 fire control system. This upgrade allowed the aircraft to effectively use advanced Falcon air-to-air missiles alongside its rocket arsenal. The F-89 Scorpion went through remarkable changes during its production run. America's first nuclear-armed defender of the skies started as a simple cannon-armed interceptor. Each new variant brought better firepower, electronics, and capabilities. Evolution through variants. From F-89A to F-89J. The Scorpion's story began on July 14, 1949, with F-89A production. Engineers planned to build more, but only 18 F-89A aircraft rolled off the line before Northrop moved to the better F-89B variant. Both models had issues with external balances on their elevators. These caused high-frequency vibrations until the team developed an internal balance system to fix the problem. These early models packed 6 20mm cannons in the nose next to their radar equipment. This gave pilots enough firepower to take down incoming bombers, but they could only use it in good weather. Northrop built 30 F-89B tickets before moving to the improved F-89C version. The C model got better engines but kept its predecessor's 6-cannon setup. These early Scorpions laid the groundwork for what would become the main production variant, one that took aerial interception in a new direction. The F-89D brought a fundamental change in air defense strategy. This game-changing variant first took to the skies on October 23, 1951, and ditched the traditional cannons completely. Engineers replaced them with an unprecedented 104 unguided 2.75-inch Mighty Mouse, folding fin aerial rockets stored in special wingtip pods. Production stopped temporarily after about 125 F-89D tickets because we needed to fix structural problems in the wings. Once fixed, full production started again in 1953. The 18th Fighter Interceptor Squadron in Minnesota got their first operational F-89D tickets on January 7, 1954. The rocket system gave pilots amazing options. They could fire all 104 rockets at once, creating a deadly shotgun pattern that covered an area as big as a football field in just 0.4 of a second. They could also choose ripple fire modes to release rockets in controlled bursts. The F-89D became the most popular Scorpion variant with 682 units built. These planes protected North American airspace through the mid to late 1950s, serving in 30 squadrons mostly in the northern United States and Canada. The Scorpion's ultimate form came through modification, rather than new production. Engineers converted 350 F-89D airframes into F-89J variants built for nuclear air defense. They swapped the standard wingtip rocket pod slash tanks for 600-gallon fuel tanks and added pylons under each wing specifically to carry the MB-1 Genie nuclear rocket. This change made the F-89J the first and only fighter interceptor to carry and launch nuclear air-to-air weapons. Each unguided Genie rocket carried a 1.5 kiloton W-25 nuclear warhead and could reach targets about 6 miles away. Service personnel nicknamed these weapons Ding Dong, as they could destroy entire Soviet bomber formations with one blast. The F-89J made history on July 19, 1957, during Operation Plumbbob, becoming the first and only aircraft to fire a live nuclear air-to-air rocket. This remarkable test showed the weapon's power, creating a fireball about 1/4 mile wide. F-89J could also carry 4 regular Falcon air-to-air missiles instead of nuclear weapons. These aircraft served with the Air Defense Command until 1959 and stayed active with the Air National Guard until their final retirement in 1969. The F-89 Scorpion became a crucial part of America's Cold War defense strategy. These twin-engine interceptors guarded everything from snow-covered Alaskan airfields to semi-automatic ground environments' automated command centers. They formed the backbone of a sophisticated defense network against Soviet nuclear bombers. Cold War deployments and operations. The Arctic represented America's most vulnerable frontier. Military strategists knew Soviet bombers would likely approach over the North Polar region at high altitude before descending toward their targets. F-89 squadrons created a defensive shield along America's northern borders to counter this threat. The 449th Fighter Interceptor Squadron's base near Fairbanks, Alaska, at Ladd Air Force Base showed this polar defense strategy in action. The squadron's aircraft stood out with their distinctive Arctic markings, and bright red accents against white backgrounds made them visible in the harsh northern environment. These boldly painted Scorpions patrolled America's most remote defensive frontiers as a powerful visual deterrent. The F-89J blended into a revolutionary command and control network by the late 1950s, the semi-automatic ground environment. This massive computer system linked multiple radar stations across North America. It created a unified air defense picture that detected hostile bombers automatically from any direction. Semi-automatic ground environment direction centers processed data from multiple remote radars at once and sent targeting information straight to intercepting F-89s. North America's first integrated air defense network eliminated delays from manual radar reporting and tracking. More than 100 operator stations filled each semi-automatic ground environment direction center. They controlled numerous airfields and missile sites, ready to counter Soviet incursions in multiple ways. F-89 crews received automated intercept vectors that guided them straight to incoming threats. Canadian inventories included F-89's nuclear Genie rockets through a unique arrangement starting in 1965. Royal Canadian Air Force crews flew these weapons in their CF-101 Voodoo interceptors. The United States 425th Munitions Support Squadron managed the technical maintenance. A complex dual-key system required both Canadian and American authorization to release these devastating weapons if World War III broke out. Tense Cold War standoffs occurred when Canadian Voodoo pilots carrying these weapons met Soviet Tu-95 reconnaissance bombers from Cuba. This nuclear air defense partnership between the neighboring nations lasted nearly 2 decades, until 1984. The final part of the video delves into the technical challenges the F-89 Scorpion faced during its development and operation, as well as the real-life experiences of the pilots who flew it. While the F-89 was one of the pioneers of the all-weather interceptor role, it also had its share of limitations and technical problems typical of the early jet era. From engine problems to complex avionics to stories from pilots who flew the Scorpion, technical challenges and pilot experiences, the F-89 Scorpion played a crucial role in America's air defense network. Yet technical problems plagued it throughout its service life. This complex aircraft pushed both engineers and pilots to their limits, despite its impressive capabilities. The Scorpion's biggest problem surfaced in 1952 when several aircraft broke apart mid-flight. 6 Scorpions crashed in spring and early summer that year. The whole ordeal reached its peak when one aircraft disintegrated before thousands of spectators at Detroit's International Aviation Exposition. The Air Force grounded all Scorpions on September 22, 1952. Flight tests revealed a phenomenon called aeroelasticity that nobody knew about before. The wing would twist at the tip during high G maneuvers and put too much strain on attachment points until they failed. Large wingtip fuel tanks made this twisting effect much worse. Northrop had to modify 194 F-89A, B, and C aircraft to fix the issue. The solution included stronger forged steel attachment points and small fins added to each wingtip tank's outboard rear. These changes reduced the aerodynamic forces that caused flexing. The fleet didn't reach its intended operational levels until 1954, after 14 months of modifications. Pilots struggled with an aircraft that had an extremely high accident rate of 383 per 100,000 flight hours. Modern fighters like the F-15 are nowhere near as dangerous, with rates around 0.5 per 100,000. The Scorpion's complex avionics just needed constant maintenance. Pilots from that era said having all systems go rarely happened. The thin wing design required tall, thin, high-pressure 200 psi main wheel tires, which made ground handling tough. Lieutenant Felix Monkla's disappearance over Lake Superior while chasing an unidentified aircraft became notorious. Official reports blamed the pilot for vertigo, which sparked controversy among people who knew the case well. The F-89 JTAC's nuclear mission required unique training protocols. Pilots trained with special versions of the Genie rocket that contained no nuclear material. Ground crews had to be ready for surprise, mass load drills to show they could arm multiple aircraft quickly. Any mistakes with inert training rockets led to punishment. Everyone assumed a nuclear Genie would get the same treatment. Training also included the Hughes MG-12 fire control system. This system lets pilots launch from a nose-high, climbing position essential to escape the nuclear fireball. F-89 Scorpions served for a long time, with the last being withdrawn in 1969. Its service life lasted approximately 17 years, and it once served as the backbone of the United States air defense, with 39 active Air Force units and 17 Air National Guard squadrons using the F-89 as their primary fighter. It outlasted the F-86 Sabre, the F-80 Shooting Star, and the F-94 Starfighter during its service career. The F-89 fulfilled its intended purpose and had a long service life. When you consider how short the service life of many airplanes during this period was, the F-89 appears even more astounding. Thank you for watching the video. If you have any interesting stories about F-89 that we have not mentioned, please share them in the comments section for everyone to know. If the video helps you entertain, please click like the video. See you in the next video.